Acknowledgement through.
Acknowledgement.
Yeah.
Can I rearrange my receiving traffic in UDP?
Not possible.
Not possible. Can I rearrange traffic in UDP?
UDP is not possible. In TCP is
TCP?
possible. Is possible.
Then how?
It is a 3 handshake.
How I can rearrange my receiving traffic in case of
Segment
TCP?
segment number.
With the help of
Sequence.
sequence number.
Yeah.
So sequencing is going to be done in TCP and sequencing will not happen in case of
UDP.
UDP. Right?
Yes.
Okay, what we call to data at transport layer?
Segments.
Segment. Very good. Segment.
Sorry, excuse me. I think we said the transport layer fragmentation. No.
Segmentation. Fragmentation at layer 3. Done by router. Fragmentation at layer 4 on the basis of how device is going to perform fragmentation, guys, on the basis of what?
MTU.
Flow control. Buffer size. Receiver buffer size.
Segmentation. Segmentation is done on the basis of maximum segment size.
MSS.
MSS. Right? And fragmentation is going to done on the basis of MTU.
Sir, excuse me. I have a question. So for clarification, for segmentation for layer 4 and fragmentation for layer 3, is that correct?
Yes, correct.
Okay, thank you. Sir, one more question, please. About the error correction. It happened twice in OSI process.
Yeah, it's happened twice.
It's layer 4 and layer 2. Am I correct?
Yes. Why we have 2 times?
Yeah, please.
See,
what's the reason?
if a network layer is generating a traffic, if your traffic is generated at network layer, then there is no role of transport layer, right? So data link layer is going to perform error correction. Done. For application layer traffic, transport layer is going to perform error correction, right? But what for the traffic which will generate it below transport layer? Data link layer. Layer 4. Right, so dividing large size of data into a smaller part of data is known as segmentation at layer 4, and dividing large size of data into a smaller part at layer 3 is known as fragmentation. Fragmentation done on the basis of MTU, segmentation done on the basis of MSS, maximum segment size. Then guys, TCP versus UDP. Differences are, which protocol is fast?
UDP.
UDP is a fast.
Why UDP is fast?
Because no acknowledgement, doesn't have acknowledgement.
Yes, because we don't have any acknowledgement.
So would you like to share your screen, please?
Oh, a screen. Yes, brother. And will receiver machine send acknowledgement after each segment? How receiver machine is going to send acknowledgement, guys? After receiving how many packets or how many segment?
I think it depends on the window size.
Window size, very good. So we have windowing. Windowing is process to reduce number of acknowledgement. So while three-way handshake, both machine is going to negotiate their buffer memory.
Exactly.
What is the use of three-way handshake?
Initiate communication between two sides.
To establish a connection, logical connection between source and destination. So client machine is going to send SYN message. SYN message means synchronization message. And what is synchronization message? It is a TCP header with SYN bit on. Correct? Header with SYN bit on. Correct, guys? Then receiver machine will send SYN plus ACK. Means TCP header with SYN plus ACK bit on. Right? And then receiver machine will send ACK. So this is how a sender and receiver will establish a logical connection. Right? This is called TCP connection. And after that, it will send the actual traffic. My client machine, sender machine is going to send actual traffic. Correct? Am I right?
Yeah.
Then
Sir,
any other
recording
difference?
is on. Sir, excuse me, your recording is on?
Yes, recording is on. That's why we are saying TCP is a connection oriented protocol and UDP is a connection less protocol. Means UDP does not perform three-way handshake and TCP perform three-way handshake. So while three-way handshake, both machines are going to negotiate their buffer memory also. On the basis of that, it will decide window size. And after receiving data equivalent to window size, receiver machine is going to send acknowledgement. Am I right? After receiving equivalent data to window size, receiver machine is going to send acknowledgement. If a sender machine will not receive acknowledgement, then sender machine is going to retransmit the data. So retransmission is also possible in case of TCP, but it is not possible in case of UDP. Right? So data means your small data or your actual data plus transport layer header is known as guys segment. Correct? Then come to network layer. So what is the responsibility of network layer? So till now you learned two protocol at transport layer. One is TCP, another one is UDP. At network layer you learned one protocol, that is IP protocol. And transport layer is, network layer is responsible for logical addressing. Addressing means adding source address and destination address. Right, so IP protocol is going to add header. And in that header there will be many more information. So we'll see those all information, right? And then data link layer, which is responsible to add MAC address, source MAC and destination MAC. So see here, you have some headers here. This is TCP header, guys. So TCP header carry these all information like source port. And what is the length of source port? 16 bits, correct? 16 bits destination port. Then sequence number, length of sequence number is 32 bits, right? So source port number can be port number from this range 10252 65535, and destination port can be 02. Destination port, well-known port number. Tell me the range of well-known port number.
02124.
Right? What is port number? Port number is unique identification of application layer protocols.
Sorry, excuse me. I think that's the 1023, not 24. Sorry about that.
Okay.
I think the
23.
well-known port number starts 0 to 1023, and then the used one 1024 till 65535, please.
Okay. Free. Then sequence number 32 bits means range can be 0 to 2 to the power 32. And what is the use of sequence number? Why we have sequence number in TCP header? because transport layer is going to divide large size of data into a smaller part. So how receiver machine is going to rearrange it, how receiver machine is going to combine multiple smaller part into single data with the help of sequence number. So guys, when client machine will send SYN message to server, let's say this is server and this is my client machine. So when it will send SYN message, what will be sequence number? 0. Right? When server will send SYN plus ACK, what will be sequence number? Sequence number is going to be 0 and acknowledgement number will be 1. Means it is giving acknowledgement of received SYN message. So server have received SYN message with sequence number 0, so it will give acknowledgement on sequence number plus 1, right? Means acknowledgement number is going to be 1. Then client machine is going to give acknowledgement. So again client machine will give acknowledgement on acknowledgement number 1, right? Because it is receiving SYN message from server on sequence number 0. So sequence number plus 1 means 1, acknowledgement number 1, right? This is how these two devices can establish a TCP connection. So these are most important information inside TCP header: source port, destination port, sequence number, and acknowledgement number. After that, guys, I have few more fields here like header length. So this field is going to indicate length of headers so that a receiver machine can find the size of actual data. Let's say a receiver machine is receiving a segment whose length is 100 bytes. And inside the header length, there will be information of header length. Like, so header length is, let's say, what, 20 byte. So what is the size of data? Can I find the size of data? Yes. So total size is 100 bytes. Out of 100 bytes, 20 bytes are header length. That means 80 bytes are actual data. Correct? So it's help receiver machine to find the actual data. It will get to know, okay, after 20 bytes, actual information is starting. Then there is reserve field, flag fields. So I have multiple flags. Why we have flags here? For flow control. Like we have multiple flags, like SYN is used to establish a connection, right? Then ACK used to acknowledge. Then FIN used to terminate the connection. So we have multiple flags under TCP header which is used for flow control. Then guys, window size. So someone of you was asking how machine will get to know window size. So actually machines are sending window size in their TCP header. So this header can be one SYN message as well, right? It can be one SYN message, means SYN bit is on, SYN flag is on. Then I can say it is a SYN message, right? There will be source port, destination port, sequence number, acknowledgement number, header length, flag, then window size. After that, checksum. Checksum field is for error detection. And then guys, urgent point. So I have one urgent point for quality of service to prioritize the data. Let's say a client machine need to send 2 segments, and this segment is important, right? Let's say client machine have 2 data, guys, data 1, data 2. Data 2 is voice traffic. This is important. I need to prioritize it. I need to send it first, and I need to tell to all networking devices between source and destination, please process this packet first, this segment first. So what I can do, I can on urgent point here, right? So with this data, when I will add TCP header, transport layer header, I will use this field to prioritize it. So these are, guys, fields, or these are the information carried by TCP header. Source port, destination, so the sequence number, acknowledgement number, header length, reserve, flag, window size, checksum, and urgent. After that, there is one option field also. So source port, 16 bits value specify the source number of sender. Destination port, 16 bits value that specify the port number of receiver. Sequence number, a number used by TCP that puts the data back in the correct order or retransmit missing data during the process called sequencing. After that, acknowledgement. 32 bits value that is expected next. You know, the use of acknowledgement is what? Actually, let's say this is my client machine and this is server. So client machine have multiple data, right? So here it will perform sequencing, sequence 1, sequence 2, sequence 3, sequence 4. And guys, size of each data is, let's say, 100 byte, 100 byte, 100 byte, 100 byte, and 100 byte. And window size over here is, let's suppose, 300 bytes. So what will happen in this scenario? PC1 is going to send first segment to server, then second segment to server, then third segment to server. Now server have received 300 bytes information. So now server need to give acknowledgement. Server need to give acknowledgement. So server is going to send acknowledgement on what acknowledgement number? 301. 301 means size of data plus 1. Once client machine will receive acknowledgement on this number, sender machine will get to know, okay, my server have received till 100 bytes of data. Right? And sender machine will get to know that, okay, receiver machine is requesting for next data. So acknowledgement number is used to identify expected next data. Then header length, it is the size of TCP header, which indicate where the data begins. Okay, so if a receiver machine is receiving a data, right, where data and TCP header is there, TCP header. So inside the TCP total length is 100 byte and header length in the TCP header is 20 byte. That means actual size of data is 80 byte, correct? Then guys, reserve field, so it always set to 0. We'll talk about it later in CCNP maybe. Then guys, flags. So it is,
Yeah, sir, one question.
yeah, go ahead.
Header length is always default 20 bits, 20 bytes.
Yes,
Sorry.
yes,
That is a
correct. And there is one
value.
optional field now. So if you will use the optional field, then size can be extended. Flags. So it is a control functions in which used to set up and terminate a session. So like we have SYN bits to establish a connection. I have a FIN bit to terminate the connection. So how many flags I have, guys, total? 8 flags in TCP header. Then window size, negotiate to the buffer memory of interface. Then checksum, used to find error in the TCP header. Urgent point, it is used to send traffic urgently. And option, it is an optional field. So we'll see the use of optional field also later. Then I have UDP header. And see guys, UDP header is going to carry these informations only, right? Source port, destination port, checksum, and header length. That's all. That's all. We don't have sequence number here. We don't have acknowledgement number here. We don't have flags here. After that, your actual data, right? So if at transport layer UDP is working, so UDP is going to add these all information with actual data, and TCP is going to add these all information with actual data, right? Then guys, I have what? IP header. So again, IP header is going to add 20 bytes information. First field is version. This field is going to identify which version of IPv4 it is, right? So at network layer, if IPv6 protocol is working, then version field is going to carry IPv6 protocol. If IPv4 is running, then it is going to carry IPv4 protocol. Then again, we have what here? Header length. What is the length of header? Then guys, again, I have one field here, that is TOS field for quality of service, for prioritizing data. then total length. See, header length means length of your header, and total length means header length plus data, length of data. So total length information will be there as well as header length information will be there. Then guys, identification field. Why we have identification field? See, as I told you, router have also capability to divide large size of data into a smaller part. So when router, let's suppose here I have router 1 which is connected with router number 2, right? And then router 2 is connected with, let's say, any other device here. And guys, MTU of this interface is 2000 byte, and MTU of this interface is 1000 bytes. So if this router is receiving a traffic whose size is, let's suppose, 2000 bytes, so router 1 need to divide it into two parts. So router 1 is going to divide it into two parts, then it will forward to router number 2. Now router 2 can combine it, and after that it can forward it, because their MTU is 2000 byte. Now question is, how router 2 is going to rearrange these two a smaller part of data, right? Which one is the first, which one is the second? So that's why we have what, guys? Identification field here. So when router is going to divide large size of data into a smaller part, it will add one sequence number again, and that sequence number is identification, identity number 1, 2. Right? So router is going to perform sequencing on the basis of this field, right? It will add the sequence number, you can say. Identification means how to identify the smaller part of data, right? Then guys, again I have flag, fragment, fragmented, offset, then time to lib. Don't worry about these fields like fragment, offset, or flags. Identification is clear, version is clear, header length is clear, priority is clear, total length is clear. Now try to understand the time to live. TTL. It is very important term in networking. So can anyone explain what is TTL? TTL means time to live. See guys, this field is used to avoid loop. This field is used to avoid loop. Try to understand one scenario. Let's say my scenario is this one. Router 1 connected with router number 2, router 3, and I have one router 4 here. Guys, here I have one network that is X. Here I have one network that is Y. X subnet and Y subnet. So by default, router 1 will have information about X network only, and router 4 will have information about Y network only, because by default router knows only directly connected network. So here you have to configure the routing. So let's say by mistake you have configured routing on router number 1 for Y network, right? So whenever you will receive traffic for Y network, please forward it to router number 2. And on router number 2 also I am going to configure routing for both network, X network and Y network. So here on router number 2 I am going to say for Y network forward traffic to R4. But by mistake I have set forward traffic to R1. Now what will happen in this scenario? By mistake I have configured wrong static route or routing on router number 2. Router 2 should forward traffic for Y network to router number 4, but I have configured it to send traffic to router number 1. Now when router 1 will receive traffic where destination is Y, so router 1 will forward it to router 2. Router 2 will check their routing table and it will find, okay, I need to forward it to router number 1. So it will forward back to router number 1. Again router 1 will forward to router 2. Again router 2 will forward to router 1. And this is what? Loop. Right? So in network you will see when we will configure the routing protocols how loop can occur, right? Loop can form in the network, guys. And now as router 1 is forwarding traffic to router 2 and router 2 is sending same traffic to router number 1 back. So traffic will be moving here between router 1 and router 2 for lifetime. For lifetime, and it will reduce the bandwidth here, right? Because unnecessary traffic is moving on this link because of misconfiguration of routing, right? In the same way, loop can form on a single segment, means on a single cable, or loop can form in this topology, right? So you will see how loop will form, but for now just understand loop is very important in the networking, guys. If there is loop in the network, that means it is going to reduce the performance. It is going to reduce the performance. So to avoid the loop, we have what? TTL filled in the IP header. Means whenever router 1 is going to forward traffic to router number 2, it will send one TTL. And by default, TTL value on Cisco operating system is 255. By default, TTL value on Cisco OS is 255. And whenever a packet cross router, TTL value will be decremented by 1, right? So let's suppose router 1 is receiving a traffic where TTL value is 255. So when router 1 will forward it to router number 2, it will decrement TTL by 1. So TTL value is going to be 254 here, right? When router 2 will forward it to router number 1 again, TTL value will be decremented by 1. So here TTL value will become 253. And guys, at a time, TTL value will become what? 0. And once TTL value will become 0, router is going to drop that traffic. It's going to drop that packet. So is it clear why we have TTL value? TTL stands for time to live, which is used to avoid layer 3 loop, or you can say which is used to avoid routing loop. So if loop will form in the topology, routers are going to automatically drop it after 255 hops. After 255 routers, you can say. And what will be the TTL value inside the IP header? That depends on your operating system. In Windows operating system, TTL value can be different. In Cisco IS, TTL value can be different. In Linux operating system, TTL value can be different. Right? So let's suppose this is my scenario. In this scenario, if PC1 is forwarding one traffic to, let's say, this server, right? Let me configure the server. IP address on the server is, let's say, 192.168.1.129. Subnet mask 255.255.255.128, and default gateway IP address 192.168.10.1. Default gateway IP address is last IP address, means 254. This is my IP address on server. In the same way, I can configure one IP on PC. So let's suppose PC IP address is 192.168.1.1, subnet mask 255.255.255.128, and default gateway is 192.168.1.127, last IP address of this subnet. Now I'm going to configure the router. So on router, let me configure IP config T, then interface F0/0, say no set, and IP address 192.168.1.254.255.255.255.128. Then interface F0/1, say no set, and here I am going to define IP 192.168.1.127, 255.255.255.0. Now tell me, can PC1 ping to server? Can PC1 ping to server, guys? Yes or no? Can PC1 ping to server? Yes, of course, yes. Because both are connected with same router. Both subnet are connected with same router. That means router have information of both networks. So let me ping. Say ping, and the IP address of server 192.168.1.129, first IP address. So see, this PC have generated one ICMP request message, and it will forward to router. So if you will open this ICMP packet here, you can see the TTL value. What is TTL value here, guys? 128. Why? Because it is a window operating system. In window operating system, TTL value is 128. But when this packet will cross router R1, when router 1 will exit this packet, it will decrement TTL by 1. So always keep in mind, whenever a router is going to receive a packet, it will decrement TTL by 1. Or not only router, you can say whenever any device who have capability to change layer 2 information. Like in my scenario, when router will receive this ICMP packet from PC number 1 on this interface, what router 1 will do, guys? It will remove layer 2 header, and then it will add new layer 2 header, right? Where source will be the MAC address of exit interface and destination will be MAC address of this server. Now in the packet, source MAC is the MAC address of PC, destination MAC is the MAC address of my default gateway. So actually R1 is going to rewrite the layer 2 header. So any device who have capability to change the layer 2 information will decrement TTL by 1. So once router will receive this packet, it will decrement TTL by 1. So here you can see TTL value is 128. Is it visible?
Yes, sir.
Okay. Now when it will forward to switch will forward it to router. This is ARP message. Wait. I think ping is not working. Bit slow. Let me check what happened, why ping is not working. Why ping is not working, guys? IP address 192.168.1.1 submit mask 127, correct? Can I ping my gateway IP address? Ping 192.168.1.127. Yes. See, I am not able to ping my gateway. So what is the issue? Let me check the router configuration. Oh, IP address is overlapping. Here submit mask is incorrect. 128. Okay. Do so IP interface brief. On fast Ethernet 0/0 IP address is this one. Do so run interface F0/0. I think I cannot run this command in packet tracer, right? So go to interface F0/0 and let me configure IP again, because I have configured wrong subnet mask 192.168.1.254. Subnet mask 255.255.255.128. Then exit interface F0/1 and say IP address 192.168.1.127, 255.255.255.128. Again it's overlapping. Both IP address belong to different network or same network? Oh,
same network.
126 is going to be last
Same
IP
network.
address. Last value, no, different network, no brother. But 27 is broadcast address. So last IP address will be 126. Correct?
Sir, no, because you know what happened. So you put the two different interface with one networking. That's why it will not work, sir.
No brother, it's working na. So IP interface brief. It's working. So do so IP interface brief. It's working on fast Ethernet 0/0 IP address is 192.168.1.254, which is connected with server switch, and 0/1 which is connected with my LAN, means PCs, where I'm running this IP address. Both IP address belongs to different subnet because slash value is 25. Slash is 25. Am I right? And PC1 can ping to server. See, it is able to ping their default gateway. Right? And this PC can even ping server as well. It's taking some time. Ping working. Now in the same way I can ping to server also. Server IP address is 129, means first valid IP address, and see, ping is working. Now I am going to open simulation mode to show you the packet. So again, let me take you to PC1 and send ICMP traffic to server. Now guys, this time you can see here TTL value is 128, correct? When router will receive it, it will decrement TTL by 1. After that it will forward to switch 2. Right. Inbound PDU means incoming traffic, TTL value 128, and outbound traffic means outgoing traffic, which router is going to send to switch 2. So here TTL value should be 127. What is happening here? See here.
It is showing the 128.
This is error of packet tracer. Let me show you here. What is TTL value? Here is the TTL value, brother. That is total length. This is TL.
128.
This is TTL value.
Yeah,
127.
Okay.
Right? Again, when server will generate reply, it will generate reply with TTL value what? 128. See the reply message. TTL value is 128. But when router will receive it, it will decrement TTL by 1. Now go to outbound packet. See, TTL value over here is 127, and inbound TTL value is 128. Clear? So why we have TTL field, guys, in the IP header? To avoid loop. Okay. Then protocol field is there. Again, this field is very important, right? Like in TCP header, source port, destination port, sequence number, acknowledgement number, window size, these are what? Important field. In the same way, under IP header, TTL field, protocol field, these are important fields. Source IP, destination IP, these are important fields. So protocol field is used to identify upper layer protocol. Upper layer protocol. See, in this scenario, from PC number 1, I am sending HTTP traffic for this server, right? So at application layer, this machine is going to generate one HTTP traffic, right, guys? Then it will hand over to transport layer. Transport layer will add source, destination port, source port and destination port. But which protocol will work at transport layer? TCP or UDP?
TCP.
TCP. So here at transport layer, TCP protocol is going to add header, where source port will be there, destination port will be there. Then it will hand over to network layer. Network layer will add what? Source IP, destination IP. Correct? Now when the server will receive this packet,
Yes.
source IP will be the IP address of PC1, destination IP will be server IP address. When the server will receive it at layer 3, it will check destination IP. Destination IP is the IP address of server, it will match. Now how network layer or IP protocol at layer 3 will came to know that I need to hand over REST traffic, means accept IP header, REST traffic to which protocol at transport layer, because at transport layer two protocols are working, right? TCP and UDP.
UDP.
So at network layer, IP protocol have this packet now. So IP protocol is going to check protocol field. And in the protocol field, there will be information about upper layer protocol. So in the protocol field, if value is TCP, then network layer is going to hand over REST traffic to TCP protocol at transport layer. If protocol is UDP, then it is going to hand over UDP protocol. Got it? So that's why we have protocol field here to identify upper layer protocol. To identify upper layer protocol. Then header checksum, again checksum. Then guys, source IP 32 bits, destination IP 32 bits. Then I have one optional field, and after that your actual data. Got it? So version field will tell you the IP version. Header length will tell you the length of header, right? And header length is 4 bits information. Then type of service is used for quality of service. Total length will tell you the total length of your data. Identification field. If IP packet is fragmented, means divided by router, that is fragmentation. If IP packet is fragmented, then each fragmented packet will use the same 16 bits identification number to identify to which IP packet they belongs to, right? Then flag. So I have 3 flag here, and again flag is used for fragmentation. So if flag is set to 0, first bit is always 0. The second bit is called DF, means don't fragment. So if you want that your router should not perform fragmentation, means your router should not divide the data, then you can turn on second bit. Second bit means don't fragment. Then your router is not going to divide large size of data into a smaller part. Okay, so let's suppose I have a scenario like this. This is my router, right, which is connected with one server. Their MTU size is 1000 bytes, right? And this router is connected with one PC. If this PC is generating 2000 byte data, can router forward it to server? Yes, because router have capability to divide it into 2 parts. After that, it will use identification number. But if I will turn off, if I will use second flag, means don't fragment, then can this PC forward 2000 byte data to server? No. Why? Because I am telling to my router to not fragment. Got it? Got it, guys? See, in the GNS3, what I can do, I can design one topology to verify it. I can design a topology to verify these things. Four-way. What is the use of four-way handshake, guys? Four-way handshake is used to terminate the connection. Right? Now let's suppose here I have one PC and one router. I'm going to change the symbol. Otherwise you will ask that this is router. So let me make it PC. Done. So this is my, let's suppose, PC or client, and this is router. Done. Now I am going to connect these two devices together with the help of one Ethernet cable, and let me turn it on. See the interface. What subnet you want to use between PC and router? You can use any subnet. Let's say 10.1.1.0. 10.1.1.0/24. IP address of router is, let's suppose 10.1.1.10, and IP address of PC is, let's say 10.1.1.1. Done. So let me access it. PC and router. Let me configure the IP. Interface F0/0, and after that, let's suppose this router is connected with one server here as well. So let me use one more router here, and I am going to use it as a server. In real time, it will be your server. So let's say this is my server here, connected with router number 2. Done. And here my subnet is, let's say 192.168.1.0/24. IP address of server is again .1, means 192.168.1.1, and IP address on the router interface is 1.10. Done. So can PC ping to server? Can PC ping to server, guys? Yes, because both are connected with single router. So router have information about both device. Both are directly connected with router. So let me configure IP on PC first. Say NoSet and IP address 10.1.1.1 255.255.255.0. Exit, and let me say NoSet as well. NoSet. Then exit. No IP routing. To disable routing, I am running this command, and then say IP default gateway. What will be default gateway IP address for PC? 10.1.1.10 means router IP address. Then go to router, config T, interface, fast ethernet 0/0, say NoSet, and IP address 10.1.1.10 255.255.255.0. Exit. Then interface F1/0, say NoSet, and IP address 192.168.1.10 255.255.255.0. Exit. So IP route. So you can see both network are directly connected with this router. Done. Then go to server, and let me configure one IP address on server. Say no IP routing first, and then interface F0/0, say NoSet, and IP address 192.168.1.1 255.255.255.0. Exit. IP default gateway. What will be default gateway? 1.10, right? Now can PC ping to server? Yes. Go to PC and ping to server. Server IP address ping 192.168.1.1. Right, I am able to ping this server. Correct, guys? Now see, I have option to say what? Don't fragment. I can say don't fragment. So if this time PC is generating any size of data, router will divide it and then it will forward to server. But if I can say don't fragment, if I will on this bit, then router will not divide the data. So if router will receive a data whose size is greater than their MTU, then router is going to discard it. Right? So here I can define the size. Will ping work? Will ping work? No. Why ping is not working? Because I have set don't fragment bit. Right? Means router cannot fragment this packet. If you will capture this link, to see the IP header, see. And without don't fragment bit on, can this PC ping to server? Can PC ping to server?
Yeah. Yes, sir.
Yes. See, ping is working, right? And you can open any ICMP packet. You can open any ICMP packet to check the flags, right? So this is my actual ICMP packet, and then IP header, network layer header. So let me open it and see the flag. Here is the flags. See, all bits are off.
0.
Right? Yes, 0 means off. But now if I am going to send ping packet with don't fragment bit on, here I am going to say df bit and then size, or
So by default size is 1500, right?
right, by default 1500. See, ping is working, right? Now if you will open any ICMP packet, see the flag. Don't fragment bit is
Means don't fragment means is not debated the packet, right?
means raw. Yes, you are telling to router that this packet is single packet. Please don't divide it into two part or into multiple part. By default, router can perform segmentation,
Okay.
right? But if you want to send any packet and you don't want that router can divide it, then you can set this bit. And this bit is reserved. This bit will be, first bit will be always 0. Second bit is don't fragment bit. Right? And then guys, third bit is more fragment bit. The last bit is called more fragment bit, and set on all fragment packet except the last one. So more fragment bit means whenever router is going to divide data into a smaller part, see, their MTU is 1500 byte. If it is receiving 2000 bytes information, it will divide it into two part. Correct, guys? It will divide it
1500
into two part because don't fragment bit is by default off. Yes, go ahead.
Okay.
Yes.
Yeah, by default is 1500, right?
By default is 1500. So
Okay.
it will
Suppose
divide
you
it
are
into,
sending the
yeah,
Suppose you sending the 2000 means 1500 plus 500.
correct. Very good.
Okay. Yeah.
Right? So after dividing large data into a smaller part, it is going to on more fragment bit. So on this fragment, it will on last bit, means more fragment bit. More fragment bit is on. So on server will receive this, it will see, okay, more fragment bit is on. That means more fragment packets are coming. This is not the complete information. This is not the complete data. More fragment parts are coming, means more fragment data is coming, means part of this data is coming, right? And last part will have this bit off, more fragment bit off. So when server will see, okay, more fragment bit is off, that means this is the last part of this data. This is last part of this data. Okay, so to see the practical, what I can do, let me capture this link also. Right, and now I am going to send ping 192 same IP address, and fragmentation is allowed. I am not going to say don't fragment, and then I am going to set size 2000, right? So router is going to divide it. So see, fragment packet, right? Fragmented IP protocol. So if you will open it and you will check, if you will see the flag, sorry, this is my actual data, IP header. So you can see the flags. More fragment bit is, guys, on. That means what? It is a fragment packet, right? And more parts are coming. More parts are coming. This is not the complete data. So first server will receive this fragment, then this fragment, then this fragment, like that. And in the last fragment, this bit will be 0, set to off.
Sir, will there be a sequence number also mentioned here?
In the fragment packet, identification number, na?
Okay.
Identification number.
Okay.
See, on the first fragment packet, identification number is 14, right? On the second fragment packet, identification number is 14. That means both are part of same
Same
data.
packet.
Same data.
Both are part of same data, right? 21. That means this fragment packet and this fragment packet are part of same data. So see, router is dividing large data into two parts, right? So you can say this is fragment 1 and this is fragment, sorry, not this one, fragment 1, fragment 2, right? Of one ICMP packet, one ICMP request message is divided into two parts. On both, identification number is going to be same, 14, 14. So receiver machine will came to know, okay, these two are part of same data, same packet, right? And more fragmentation bit on means more fragment packets are coming. And if you will set don't fragment bits, then router cannot divide it. Router cannot divide large data into a smaller part. So hope IP header is clear, guys. Each field of IP header is clear to you. What is the use of identification field? What is the use of flag? So first bit will be always 0. What is the use of protocol? Protocol field means to identify upper layer protocol. Time to leap to avoid loop. Source IP is going to identify source sender machine. Destination IP is going to identify receiver machine, and after that your actual data.
Sorry, excuse me.
Yeah.
I have a question. So in on GNS3, so how many bytes each packet in that lab? Can we see how many bytes each packet, please?
Size of data, yes, you can, brother. See na here. ICMP
Yeah,
message,
please.
just
Thank you.
open any ICMP message, and in the IP header there is one field called total length. So you can check total length as well. So let me open the ICMP request message and see the total length. Total length of this ICMP request message is, guys, 520 bytes. Got it? So 20 bytes
Thank
are
you.
header. That means actual data is 500 bytes. Right? Header length is 20. Total length is 520. That means actual data size is 500 bytes. Got it? And even we can set the size. Like I can say ping, then IP address after that size. Then guys, why we have fragment offset. So this 13 bits field specify the position of original fragmented IP packet. Time to live. Every time an IP packet passes through a router, the time to live field is decremented by 1. Once it hits 0, the router will drop the packet. Protocol, this field tells us which protocol is encapsulated with IP packet. For example, TCP has value 6, means protocol number of TCP is 6, protocol number of UDP is 17. Now guys, let me tell you some protocol number of some protocol, like TCP protocol number is 6, UDP protocol number is 17, ICMP protocol number is 1. So this is a server who is receiving a packet. It will check IP header. Inside the IP header there is one protocol field. So if in the protocol field value is 1, that means IP protocol is going to hand over actual data to ICMP protocol. If value is 6, then IP protocol is going to hand over data to TCP protocol. If value is 17, then it is going to hand over data to UDP protocol. So in your scenario,
Suppose
you can see the protocol number in the IP header. Just wait. What is the protocol number, guys? 1. That means it is a ICMP protocol. And TTL value is 255. Right? But if I will send telnet data, from PC to server, say telnet and 192.168.1.1. Now let me show you the telnet data. Here, see the scene message. So over here under IP header, protocol is going to be what? 6. That means upper layer protocol is TCP. So receiver machine will get to know, okay, I need to remove IP header, and after that I need to hand over REST information to TCP protocol, right? Right? If I will send DHCP packet, let me say config t interface f0/0 IP address DHCP. It will send one discover message. Are you able to see the discover message? So guys, in this discover message, in the IP header, protocol number is going to be what? 17. That means upper layer protocol is UDP. Is it clear? Is it clear to all?
Yes, clear.
Yes.
Suppose protocol is 80 HTTP means in protocol field is 6, right?
That is what other. See, at network layer need to hand over traffic to either TCP or UDP at transport layer, or to any protocol to network layer. Like there are multiple protocol at network layer, that is, let's say EIGRP, OSPF. So if this router or this server is receiving OSPF packet, means any message of OSPF, then protocol number will be protocol number of OSPF, right? If it is receiving a traffic of BGP protocol, then BGP is an application layer protocol which uses TCP at transport layer. Then again, protocol number is going to be 6. Got it?
Santosh, that is application layer protocol which you are asking.
Yes.
Yes.
And HTTPS.
So HTTPS is an application layer
Is
protocol,
80.
right?
Yeah, this is a
So source port is going to be random port
443.
number.
Yeah.
443 is going to be destination. Network layer will have what information? Source IP 10.1.1.1, destination IP 192.168.1.1, and protocol number 6, na brother, because see,
Protocol 4
network layer have received the information from TCP protocol, right? So TCP protocol is encapsulated with IP. Encapsulation means what? Adding extra information. So this information is encapsulated with IP header, right? With IP protocol. So which packet is encapsulated with IP packet? TCP packet, right? Then source port, source MAC, destination MAC, PC1 MAC address and server MAC address is going to be, not default gateway MAC address will be destination MAC address. Then guys, here we will have one type field. Type field which will specify upper layer protocol, means network, at network layer which protocol is working? IP protocol. So in the type field there will be information about IPv4, right? So when server will receive it, first it will check destination MAC. Okay, if destination MAC will match, then it will accept, and it will check type field to know which is upper layer protocol. It will get to know, okay, upper layer protocol is IP protocol. So it will remove this header and it will hand over all rest information to network layer. Network layer will check destination IP. Okay, destination IP is matching. Let me check the protocol field. Okay, protocol field is 6. That means let me remove these all information and let me hand over these all rest information to TCP protocol. When TCP protocol will receive it, it will check destination port. Okay, destination port is 443 and 443 is enabled over here. So let me remove this header and let me hand over actual data to TCP protocol. This is how it will work. Is it clear now?
FTP also same?
Yeah, FTP also same. If port number is 21, then transport layer is going to hand over it to FTP protocol. If port number is 61, then DHCP, right? Then difference between segmentation and fragmentation, you already know this. Then guys, you have some application layer protocols. First is HTTP. So you know how I can perform lab of HTTP. What is HTTP protocol? Hypertext transfer protocol. Port number 80 uses TCP at transport layer. See, to learn any application layer protocol, you need to learn 4 things. What port number they are using, what service they are using at transport layer, and what is the use of that protocol. Only these 3 things, not 4 things. What is the use of that protocol, what service they are using at transport layer, and what is their port number. Then hypertext transfer protocol, which is secure, right? The difference is only HTTP is not secure, HTTPS is secure. Both protocols are used to access web page from web server. It is used to access web page from web server, and both protocols uses TCP at transport layer. Then guys, you have 1 minute. Then you have what? Telnet protocol. So telnet port number 23. So if destination port at transport layer is 23, then transport layer or TCP protocol is going to hand over actual data to telnet protocol, right? If destination port is 443, then TCP protocol is going to hand over it to HTTPS protocol. If destination port is 80 in the TCP header, then it is going to hand over actual data to HTTP protocol, right? Then I have secure cell. So what is telnet? Telnet is a protocol which is used to take remote access of networking devices. As I told you, your devices, networking devices are in Delhi and you are in Bangalore office, and you have IP connectivity. So you can access your devices remotely with the help of protocols like telnet and SSH. So again, for remote access, we have 2 protocols. One is telnet, another one is
RTP.
SSH.
Remote desktop.
SSH. right?
Yeah.
SSH and Telnet both are used to take remote access of networking devices. Telnet port number 23, SSH port number is 22. Again, both are uses TCP protocol. What is the difference? Difference is Telnet is not a secure protocol, SSH is a secure protocol. So in real time you will use SSH, right? But configuration of Telnet is easy. So that's why for the lab purpose, most of the time we are using Telnet protocol, right? Because by default Telnet is even enabled on Cisco routers. Then guys, you have which protocol? FTP protocol, file transfer protocol. Uses port number 20 and 21. Again, which protocol at transport layer? TCP. Used to access file server, right? To save the file, to download the file from file server, from the storage server, you are going to use this protocol, FTP protocol. Like in this scenario, in the packet tracer, see I have one FTP server, correct guys? First of all, let me do one thing. Let me set up the IP address on all server so that we can perform the lab as well. So IP address of DHCP server is 192.168.1.130. Subnet mask 255.255.255.128. Default gateway IP address 192.168.1.254. Done. Then I need to configure DHCP service here so that my client machines can get IP address from DHCP server. So this PC can get IP address from server. So how you will configure DHCP pool here, guys? Go to services, then DHCP, you can turn it on. By default it is off, so let me turn it on. Then I can create one pool. Let's say pool name is Cisco. Then default gateway IP address for clients machines is, for PCs default gateway IP address is 192.168.1.126, last IP address, right? Right, DNS server. Okay, let's suppose DNS server IP address is 8.8.8. Starting IP address 192.168.1.128. First IP address. Starting IP address is from 1, right? Because here my subnet is 192.168.1.0. So starting IP address will be 192.168.1.1. Subnet mask 255.255.255.128. Maximum number of IP addresses 126, right? Then you can define TFTP server IP address as well.
Sorry, excuse me.
Yeah.
In your lab, you have DNS server. Would you mind put the IP address of DNS server?
Yeah, I
Because
can
you
configure
have
the
you
DNS
have it
server.
in your lab.
See, first of all, I have set
Sure.
up the DHCP server here. Now my client machine can get IP address from DHCP server. So let me try these machines are able to get IP from DHCP server or not. No. Till now these machines are not able to get IP. See, this is IP address from APIPA, right? Incorrect IP address 169. It should get 192.168.1.1. So the reason is my router is not forwarding broadcast message. To get IP address from DHCP server, client machine generate a discover message, and discover message is broadcast, and router is not going to pass the broadcast message. So I have to configure helper address, right? As we discussed it in previous class, that here I have to tell my router that, brother, whenever you will receive a discover message, I know that is broadcast, you cannot forward it. So let me do one thing. Let me convert broadcast message into unicast and then forward it to this address, IP helper address. IP address of DHCP server 192.168.1.130, right? So I have configured the IP address of DHCP server on router. Now whenever router will receive broadcast message, it will convert that broadcast message into unicast, and after that it will forward to DHCP server. And now I am expecting that my client machine can get IP address from DHCP server. Let me try. So yes, you can see 192.168.1.1. Subnet mask is also correct. Default gateway IP address is also correct. DNS server IP address is also correct. Right, guys? In the same way, PC2 can also get IP address from DHCP server. So let me say IP DHCP. Click on DHCP. See, this machine IP address is 1.2. In the same way, PC3 can also get IP. I'm going to perform lab of all application layer protocol here. This machine IP address 1.3, PC4, PC4 IP address is 1.4 and then PC5. So all client machines are able to get IP address from DHCP server. Now I need to set up HTTP on HTTP server. I need to create one domain, website, right? And domain name is www.pmnet.com. So click on HTTP server, then go to services and then HTTP service. By default, both services are enabled. As I told you, this is coding, so you can manipulate it. I can say welcome to PM networking. This is my website designing. Right? Our courses can be let's say CCNA, then CCNP. Like this you can design website, right? Now I have designed the website, guys. On this server I need to set up what? DNS server, correct? But these machines have what? DNS server IP address 8.8.8, correct? So these machines will send DNS query to 8.8.8. But as you can see, I have my own DNS server. So on DHCP server, I am going to correct DNS server IP address. Otherwise, my client machines cannot access my website. So go to services, then DNS, and here I am going to modify this entry. I am going to say DNS server IP address is 192.168.1.131.
132.
130 DNS server.
Yeah, 132. Yeah, 130. Oh, yeah, sorry, 131.
131. Now
Yeah,
can
sorry.
these client machines access HTTP server or can access my website? First of all,
We
I need to configure
we
IP
enable the
again.
HTTP.
See, this time DNS server IP address is still 8.8.8. What happened? I think I have not saved the entry. DHCP. Yes, still DNS server IP address is 8.8.8, 192.168.1.131, and let me save it. Now I have saved it. Now again, if I will request for IP address, this time I will get IP address of my DNS server. Yes, you can see DNS server IP 192.168.1.131. So can I access my website? Go to the browser and type www.pmnet.com. But I cannot access my website with the help of domain name. I can access my website with the help of IP address. Reason, I have not set up the DNS. I have not created any entry on DNS server. So here I can say www.pmnet.com. So see guys, I am not able to access the server. But if I will put the IP address of my HTTP server, that is 192.168.1.129, you can see I have access of my website. Correct? Correct?
Sir, how can you access that server without configuring HTTPS?
I have configured the HTTPS, no brother, here. HTTPS service is enabled. You can see both services enabled on the server. So to access this website through domain name, I need to set up DNS. So click on DNS, and first of all, I need to configure IP on DNS. So IP address of DNS server is 192.168.1.131. Subnet mask is 255.255.255.128. Default gateway IP address is 192.168.1.254. Correct? And then go to services, and in the DNS, let me turn it on. And let me create the domain name. One entry, www.pmnet.com, and IP address of this server is 192.168.1.129. right? Let me add this entry. Now this client machine can access my website with the help of domain name, because DNS is configured and DNS have one entry. DNS have IP address for pmnet.com. So see www.pmnet.com. What happened? Why it's not working? pmnet.com. I have to check the domain name again on DNS server. Let me take you to DNS server here. Why it's working slow? My domain name is pmnet.com, correct? IP address of this server is 192.168.1.31. Default gateway IP address 192.168.1.254. Everything is fine. So let me check, am I able to ping my DNS server first? Don't know why it's slow. So I can ping DNS server, ping 192.168.1.131. And guys, I am getting reply. That means DNS server is reachable.
Working.
And this machine have correct DNS server IP address. Yes, this machine have also correct DNS server IP address. So this machine should able to access my website with the help of domain name. Or let me try it from another PC because it's taking too long time.
Yeah, HTTP service is enabled, right?
Right.
Okay. In
But
PC1?
in PC1,
Yeah.
why you will enable HTTP service in PC1, brother? On the server, na? PC1
Yeah,
is not HTTP server.
but you have to access the services, right?
To access the services, we need to enable HTTP over here. HTTP should be enabled on HTTP server, not on the client machine. Not responding. What happened to the packet tracer? Okay, let me do one thing. Let me design one easy topology in packet tracer. Till then, let me discuss another application layer protocol. We'll perform lab of all FTP. We did the lab of HTTP, HTTPS, Telnet in the last class. We'll perform on lab on SSH also. We'll perform on lab on FTP, on TFTP, right? So see the difference between FTP and TFTP, guys. What is FTP? Port number 20 and 21 used to access file server. Uses TCP protocol at transport layer. We can browse the file in FTP, means we can search file. But in the TFTP, you have to provide exact path. So generally in real time, for the storage, to store the file, we are using FTP server, and to store the configuration of devices. Like I need to backup of all networking devices on a server, means configuration backup. I need to copy configuration of my router switches on a server. So I can backup of all networking devices on TFTP server, right? So in TFTP uses UDP protocol at transport layer, port number 69. Here you cannot browse the file, means you cannot search the file. To access the file, you have to provide exact path. But TFTP is faster protocol as compared to FTP. Then guys, we have what? NTP, Network Time Protocol. So let me do one thing. Let me drag and draw some PCs here. Let's say PC 0, PC 2 connected with one switch. Then I have some server here. Let's suppose 2 server. And I have one switch. So server can be in my network, or it can be in different network also, right? But in my scenario, server is in same network. Let's say server, this server is my FTP server, file transfer server, right? And IP address of FTP server is, let me write here the IP. Let's say IP of this server is 10.1.1.1/24. IP address of this server is 10.1.1.2/24. IP address of this PC is 10.1.1.3. IP address of this PC is 10.1.1.4. IP address of this PC is 10.1.1.5. Done. So let me configure IP here. 10.1.1.1 subnet mask 255.255.255.0. Is default gateway required? No. Right? Then to this server, let's say IP address is 10.1.1.2 255.255.255.0. As all devices are in same subnet, default gateway is not required. To this PC, I am going to configure IP 10.3. So 10.1.1.3 subnet mask 255.255.255.0. Then go to PC1. PC1 IP address 10.1.1.4 255.255.255.0. Done. So let's say this is my FTP server. So first of all, I need to turn on this service, FTP service. So go to services, and in the services you can see you have one protocol, FTP protocol, and by default this is enabled. And guys, there is one user as well by default. Username is Cisco, password is also Cisco. And on the FTP server you can create the user. Means you can create user ID and password for your employees. Let's say on the FTP server, I want to create one user with name admin and password admin @123, right? And this user can write, read, delete, rename list. Okay, save it. So I have 2 users on this FTP server. Done. Now let's say from this PC, on this PC I have one file. So what I can do, I can create one file here. So go to, let's say, text editor, and here you can create one file. Let's say hello, how are you guys? Hello India. This is CCNA class. Done. Now I can save this file. So save it, and name, let's say ccna.txt is the name of my file. So I have created one file here, right? You can check it, you can verify the directory. In the directory you can see your file. So if you want to check the directory, simply you can run command dir and see in the directory you have one file with name ccna.txt. Now guys, you want to save this file on FTP server, right? So to upload the file on a server, on a file server, which protocol you are going to use? FTP or TFTP? Yes or no?
TFTP.
You can use TFTP or FTP, right? So say
Both of
FTP.
them.
Yes, both are used now.
Yes.
Say FTP and then IP address of FTP server. How to access FTP server?
FTP enable.
FTP, after that 10.1.1.1. It is asking for username, right? So let's suppose I am admin, so my username is admin. Then it will ask me for password. Admin spelling is wrong, so that's why it have declined the access. Name is admin and password is admin at the
Admin.
rate 123. So now you can see I have access of my FTP server, right? Now to upload file on FTP server, you will use command. See how many command you have here, how many options you have. Put. You will use put command to upload file on FTP. So let me say put and then name of your file. Name of your file is ccna.txt. Right, so see 31 bytes information is copied. Now go to TFTP server and here you can see you will have one file. Yes or no?
Yes, sir.
Right? So this is how you can upload data on FTP server. And let's suppose this PC1 want to download this file from FTP server. Again PC1 need what? Access of FTP server first of all. So this user should have one user ID and password. And that should be configured on FTP server. So let's suppose PC1 have user ID and password. So this PC can access FTP server, say FTP, and then IP address 10.1.1.1. It will ask for username. Let's say my username is Cisco. My password is also Cisco. This is default name. Now I have access of FTP server. So to download any file from FTP server, simply I can say, and see if you want to check the directory of FTP server, here also you can run command dir. So see, these are file and I have one file with name ccna.txt. So this is my file which I want to download. So simply I will use command get and the name of my file ccna.txt. See, right? Now exit it from here, right? Now you can check the directory of your PC. Yes, you have this file. So this is also one application layer protocol, guys. And see the simulation. In the simulation, when I will type, first of all, let me exit from here. And I am going to say this time FTP and the IP address of FTP server. It has generated one packet. Which packet it is? FTP packet. Not FTP packet. One FTP and one is TCP. Why TCP? Because FTP is a protocol which uses TCP protocol at transport layer. So first it will establish a connection by sending SYN message. Am I right? So in the SYN message, what will be destination port? Destination port is
Switch
21. Port number of FTP.
FTP.
Source port number, random port number. Source IP address of PC. Destination IP address of FTP server. Source MAC address of PC. Destination MAC address of FTP server. Because both belongs to same network. Am I right, guys? Now see the information here. This is your actual data. Means TCP header, source port, destination port. So with the help of destination port, server machine will get to know, okay, this actual information is for FTP, right? With the help of what? Destination port number. So on server will see destination port is 21. It will get to know, okay, I need to hand over actual information to FTP protocol. Actually, this FTP will receive this traffic, this packet at which layer? At physical layer. Then it will convert it into frame, right? Then data link layer is going to check what? Destination MAC. So destination MAC is the MAC address of server. Okay, it will accept. Then it will check what? Type field. In the type field, see value is what? 0x0800. This is type code of IPv4. So with the help of this type field, layer 2 will get to know, means layer 2 protocol, ARPA protocol will get to know, okay, I need to remove this header and I need to hand over rest all information to IPv4 protocol. Then IPv protocol is going to check destination. Okay, destination is 10.1.1. Okay, my IP address. Let me check protocol field. So where is the protocol field?
Is there not there?
Value is 6, and 6 is the protocol number of TCP. So IP protocol will get to know, okay, I need to hand over upper information, rest information to TCP protocol. So IP protocol will remove this header and will hand over it to TCP protocol. Then TCP protocol will check what? Destination port. So destination port is 43. Okay, it will remove this header and it will hand over actual information to FTP protocol. Got it? Got it, guys?
Yeah, got it.
Yes, sir.
Right?
Can you show me the TFTP?
TFTP server. So let's suppose this server is
Yeah.
my TFTP server. TFTP. Okay, and guys, I have some configuration on this switch. Let me do some configuration on this switch. So by default host name is switch. So I'm going to change host name. Let's say host name CCNA lab switch. Now my host name is CCNA lab switch, and I want to save my configuration. Like here I have only host name configuration, but in real time you will have lots of configuration. So you need backup. So I want to save my entire configuration on this TFTP server. So first thing is TFTP service should be enabled over here. So let me show you TFTP service is enabled or disabled. Enabled. Correct, guys? Now
Yeah.
I want to save my configuration on TFTP server. So simply go to switch and say copy running configuration data to TFTP, right? Hit enter. Now it is asking you address, means IP address of TFTP server, where you want to save it. So IP address of TFTP server is 10.1.1.2. Then it is asking you destination name. So it is saying by default name is going to be CCNA underscore lab underscore switch dash config. If you want to change the destination name, you can set the name here, otherwise you can hit enter. And now it is saving your configuration, right? It is saving your configuration on TFTP server. So just wait for some time. It will copy all running configuration data into TFTP. It will save all running configuration to TFTP.
Only TFTP you using for running configuration storage or other purpose also use?
You can upload book also, no, like this. You can upload file as well on TFTP server. But the difference is both are used for file access service, to access file servers. The difference is here you can browse the file, here you cannot browse the file. Right? So
In TFTP you browse the file, right?
So there is some error opening FTP server 10.1.1.2. What happened? Let me do one thing. Let me try again. IP address is 10.1.1.2. File name is going to be same. Is TFTP service enabled here? Yes, TFTP service is enabled, and IP address is also correct. But then too long. I'm getting some error here. I don't know what is happening. This switch don't have any identity till now. Let me try now. I have configured one IP here, 10.1.1.2. Destination name is same. Even I can save my configuration on FTP server. I can say copy running configuration to FTP. Set copy run configuration to, let me say, FTP. Then IP address of FTP server 10.1.1.1. File name is same. FTP username and password is not set. IP address of my FTP server is same 10.1.1.1, correct. Address 10.1.1.1. Destination file name, let me say CCNA and CCNP. FTP username or password is not set, please set and try again. User is already there. There is some error. Like this, you can check these things. You can configure this protocol. It will work definitely. There is some error. These are simple protocols. Interface F0/0, say IP address 10.1.1.10 255.255.255.0. Exit. Copy running configuration to TFTP. IP address 10.1.1.2. Destination file name same. My router interface is down. It will not work. Interface F0/0, say no set. And now copy running configuration to TFTP 10.1.1.2. File name is same. It will work in your scenario, right? This is error of packet tracer, guys. Like this, you can save the configuration, right? And we will perform on one lab on it, like how to take backup of networking devices, or how to reset the password. Let's say someone have configured the password on router, right? And you need to reset that password. So how you are going to copy the configuration on a server, then how you are going to reset the password, and then how you will copy again configuration from server to the router. In that time, we will see this configuration.
Sir, iOS also.
See, right now I am getting timeout error. Ping 10.1.1.2. Even I am not able to ping TFTP server. I think there is some misconfiguration. 10.1.1.2 subnet mask is this one, correct? Just wait. Let me ping now. Now this time ping should work. Yes, now ping is working. Let me say copy running configuration to TFTP destination IP address of TFTP server is this one, default name. Yes, now you can see it's working. Correct, guys? 1101 bytes is copied. Now you can check the directory of TFTP server. You will have one file with name. This one you can see. This is what? Configuration of your switch. Right? Now what I will do, if I will reload this switch, then I will load the configuration. But I have my configuration on TFTP server. Correct, guys? I have configuration on my TFTP server, so I can copy configuration from TFTP server to switch. Right? So you can see now
Yes,
again
sir.
the default host name is switch. Right? So now I need to copy configuration from TFTP to this switch. So simply I need to configure one IP here. IP address 10.1.1.100.255.255.255.0 and say no set, and now I can say copy. This time TFTP to running. This time I am copying configuration from TFTP server to my running configuration. So it is asking IP address of TFTP server 10.1.1.2, then source file name. So file name is, guys, CCNA _ lab, or I can copy the file name CCNA _ lab _ switch -config switch -config. Destination file name is, let's say, same. Failed 10.1.1.2. Source file name is, let's say, Cisco. Source file name is this one. Can I copy this name? Okay, name is like this: CCNA _ lab _ switch -config. Destination file name is, let's say, Cisco. What happened here? Source file name. Okay, source file name is the name you want to give on switch. So let's say that is Cisco. So in the TFTP, this is the problem. You have to provide the exact path, right? You cannot browse it. Like there are multiple files on TFTP server, I cannot browse it. So CCNA _ lab _ switch. Again it's saying invalid. We'll have one lab, by the way, on it. Source file name is the name of file, which is CCNA _ lab. CCNA _ lab _ switch, then config. Done. Done. And now you can see name of your device is what? Earlier name was switch.
Yes, sir.
Right? That means I have copied all configuration from TFTP server to this device. In the same way, I can back up to this router also. Right? Here also I can say copy my running configuration to TFTP, then IP address of TFTP 1.1.2, then file name, let's say router configuration, router, underscore configuration, like this, right? 613 byte is copied, right? Now on the TFTP server you have backup of switch as well as router configuration. In the same way, in real time you will have lots of devices, guys, and for all devices you will have backup on the server. Then next protocol is
Sir, excuse me.
yeah.
I have a question. Come again, what's the difference or what are the difference between TFTP and FTP, please?
Brother, in FTP you can browse the data if you have one file, right? This is FTP server and this is TFTP server.
Right.
First difference is FTP is TCP based protocol and TFTP is UDP based protocol. TFTP is faster as compared to FTP. Now see the main difference. Here you have multiple folder, CCNA, CCNP, right? And in each folder, guys, there are some books, right? It's C1 book, C2 book. Again, on TFTP, you have two folders, CCNA and CCNP. In both folder, you have one book, C1, C2. See, if you want to download C1 book from the TFTP server, so you can browse it, you can search it, you can search C1 book, right? But on the TFTP, if you want to download TFTP book from the C1 book from the TFTP server, so you have to provide the exact path. So exact path is under CCNA folder. I have one file with name C1. So this is the main difference. You cannot browse file in the TFTP, means you cannot search the file in TFTP. You can search the file in FTP. Right?
Thank you.
So we discussed three difference. Then guys, NTP protocol. See why time is important for troubleshooting, so that whenever any issue will occur, all devices is going to generate log, right? Let's say there is some connectivity issue between router and switch. How you will troubleshoot it? First of all, you are going to check the log, and log will have time, guys, timer, right? Each log message will have one time. So you can find that this device have generated this log at what time. And if time is same on both device, then it will help you to troubleshoot, correct? So that's why we have what? NTP protocol. So NTP protocol is used to synchronize time on all networking devices. So if you suppose if you have one server, that is NTP server, who is going to provide time to all networking devices, means your all networking devices are going to synchronize time with that server, with NTP server. That means time on all devices is same, correct? So we can perform on lab on NTP also. Then I have DHCP. We already did lab on DHCP, right? And till now we configure DHCP on a server, on Windows server. But guys, you can enable these services on router as well. Means you can use router as a DHCP server as well. Let's say you have 100 employees in your company, right? Or let's say 20 employees in your company. They all are connected with switch, and switch is connected with router, and router is connected with firewall, then firewall is connected with internet. So in this scenario, you don't need to set up DHCP server, right? Even you can configure DHCP service on your router. Okay? You can configure DNS service on your router. You can configure NTP service on your router. So like this is my network, and like this I have lots of routers, lots of switches are there. So I can assume that okay, my router 2 is my NTP server. So I will enable NTP service on router number 2, and then I will tell to all networking devices that NTP server IP address is this one, means IP address of router 2. So all devices is going to synchronize their time with router number 2. In the same way, I can configure DHCP service on router number 2, so that my all client machine will get IP address from DHCP, right? So let's suppose router 2 is my DHCP server. So see how to enable DHCP service on router, guys. Say IP DHCP pool, and name of pool is, let's say, CCNA. Then I am going to say define network. Network is 10.1.1.0, subnet mask 255.255.255.0. Then default router IP address 10.1.1.10. Then DNS server IP address 1.8.8.8. Like this I can configure DHCP on router as well. Now this client machine PC can get IP address from DHCP, right? You have capturing as well. So if you want to see the capturing, now go to client machine and say IP address DHCP. Interface F0/0, say IP address DHCP. See the discover message. Discover message. Then offer message, request message, acknowledgement message. DHCP work on DORA process. Client will send first discover message to discover the DHCP server. Then DHCP server will send offer message to offer an IP address. After that, client machine will check that IP address is duplicate or not, and then it will send request message. After that, DHCP server will send acknowledgement finally, right? And now you can see
Okay.
the client machine have got the IP address 10.1.1.2. Subnet mask this one. Done.
Yeah. Yes.
So we can enable these services on router as well. We don't, if my network is small, then I don't need to purchase a specific server for DHCP or for NTP. In the same way, on this router I can enable NTP protocol as well.
Yeah, we will do tomorrow, sir. Next class, we will practice first these things.
Yeah, so you have few more application layer protocol, NTP, DHCP, then DNS. So these are important protocol. You can perform lab on these all protocol. One lab on these all protocol by yourself. After that, in next class, we will discuss packet flow. Okay. Now, if anyone have
Yeah,
question,
thank you,
guys,
sir.
please ask. Otherwise, I am sending recording. So till now, we have covered basic network fundamentals, basic networking devices, hub, switch, router, firewall, right? Basic things about these devices. I'm not talking about the deep configuration or details configuration, right? Basic configuration, how these devices forward traffic. Then we understand how to connect these devices together. So we have multiple types of cables. Then we understood how to configure IP addresses, right? How to configure IP addresses, how to perform subnetting according to our requirement, and then how to assign IP addresses to devices. I have two options. Static, we can configure IP addresses statically, or I can set up a DHCP server. So it will provide IP dynamically. Done. Then after IP addressing, we understood how machines are going to generate a data, right? How machines are going to generate a data, what extra information devices are adding to forward data to correct destination. So these all points should be clear to you, then only you will understand routing and switching or wireless, any advanced technology. Which day it is? Day
9.
Day 9, CCNA and CCNP. Let me share the recording with you. Any question till now? Whatever
No, sir.
topic I have covered, guys, please make sure you are clear with those all.
Yes, sir. Thank you today.
Please perform lab of these all application layer protocols in GNS3 or in EVNG. Capture the link, check the data. Like if discover message is broadcast, check what is the source IP, destination IP, how to configure helper address on router, why to configure helper address. Okay, and because day by day we are going to now start advanced topics. Tomorrow we will see the packet flow, after that we will start the routing, right? Or maybe first we will discuss switching. So after the routing and switching we are going
So
to
do
learn
we have class
advanced.
tomorrow
Which day?
on Monday?
Monday? Yeah, Monday.
Today it's Friday.
Today is Friday, no? So
Okay.
yes, next class is on Monday.
Yeah. Okay, sir.
Okay, so
Thank you, sir.
9.
Hello, sir.
No, any question? Yes, brother, go ahead.
Sir, sir, I have one question.
Yes.
Sir, in application layer SSH and in application layer SSH
In the
and
application layer
telnet, are
SSH.
they using
Sorry, your voice is
very
breaking, brother. Please
less
speak
secure
again.
protocol, sir? Is there any reason? Both are, yes, sir. Now my voice is audible.
Yes, now you are audible. Tell me. No, see, before routing, we have few more topics, guys, like memory of router. As I told you, how to break the
Hello,
password on routers, right? So we'll cover these topic first.
hello.
Yes, brother. Now you are audible. Please speak. Hello.
Sir,
Yeah. Yes, Himnath.
so you're not audible.
Oh, I am not audible.